Welcome to Section 6, Video 4, Adding Functionality to our Sub-Interactable Objects. In this video, we're going to add functionality to our interactable actors. First, we're going to work on our door interactable, so inside of our blueprints, gameplay elements, inside of our interactables folder, and we're going to open up our door interact blueprint. Inside of the event graph, we're going to add event on interact, and we're going to right click on event interact and select the add call to parent function, calling the parent version of onInteract. And we're going to drag out of the blueprint version and call sequence. And we're going to connect the then1 execution pin to our parent onInteract and connect our interactor to the other interactor. And out of the then0 interaction or execution pin, we're going to call flip-flop. Out of A for our flip-flop, we're going to use set relative rotation. And we're going to use our static mesh in parentheses version, which will automatically connect in the static mesh from our components, because it needs a component to set its relative rotation. And we're going to set its Z to -90. And then we're going to just select this again and duplicate it by pressing Ctrl W and then connect it to B and set our Z back to 0. Let's compile, save, and I'm going to explain what this all should do. So here what we're doing is when this actor gets interacted with, we're going to first rotate the actor 90 degrees or the door 90 degrees. And the flip-flop node it will check to see if it already went through A. If it did, then it's going to go through B when it gets called again, and vice versa, which will alternate as the description says. So if we rotated 90 degrees, then rotate it back 90 degrees to 0, and then 90 degrees, 0, so on. And every time we interact, since this is a sequence node, it will go to this flip-flop, execute one of these two, and then it will come back to the sequence and then fire off the next execution pin in the sequence, which is the parent onInteract, which will just print out a message in our output log for who interacted with it. Let's quickly test this by dragging our door into level. I'll place it right over here. I'm going to rotate it about 90 degrees, and we hit play. And if you pay attention in the output log, at the bottom, I should interact with it. The reason why it's not working is because we haven't connected our player yet though, which we're going to do in a future video. So now let's fix our bouncing cube to also interact correctly by opening up our bouncing cube interact blueprint. And here we already have it for when it receives damage. We're going to add a event on interact and drag out of our execution pin and enter in a branch, or if you're just in the regular graph, you can hold the B key and then left click, and it will create a branch for us automatically. Say hotkey for blueprint. Then we're going to drag our cube into the event graph and drag out of the cube and get is simulating physics. So organize this. And we're going to plug in our return value to the branch, which in Blueprint, a branch is an if-else statement. If it is simulating physics, then it will go to true. If it is not simulating physics, it will go to false. And if you want to do an else-if statement, you would just create another branch and connect it to the false, and then so on and so on. And then the final false, which in our branch tree would be the else statement. So, out of the true, we're going to add impulse to our cube. And then what we're going to do is drag out of the impulse and use multiply by a float for vector times float. And our Z is going to be +1. So it goes in the world up direction. And then we're going to drag in our jump strength and connect it to the float value. And this will cause our player to jump. And let's also check velocity change, so that way we don't have to worry about making the number very high like we did with hit strength, which the add impulse set location does not account for that within Blueprint. Then out of this execution pin, we're going to draw a debug string. And for our text location, we're going to use the get actor location. And our text will be, I'm happy to see you, and then a little smiley face maybe. Let's change the color to purple. Since we have the damage color being red, let's make this purple so we can easily see it. And the duration, let's set it to 2.5. Let's compile and save. And if we right click on event on interact, we won't have a parent function to call, since this is only within Blueprint and it only inherits from actor, which the actor class does not have this interface implemented automatically. So here we're checking if it's simulating physics. If it is, then add an impulse where it jumps up, causing the cube to bounce. And then we draw a little message saying, hey, I'm happy to see you, nice to meet you. It's whatever you want, really. So we can save, and let's go back to our content browser, and let's open up our MPC Interact blueprint, since we already placed our bouncing cube within the level. And in here, we're going to call the event on interact. And since this is blueprint only, we won't have to call a parent function. And out of the execution pin, we're going to set the actor rotation. And we're going to get our interactor actor. And we're going to get its actor location. And then we're going to get our actor location, which we can just actually duplicate this get actor location node. And it will automatically use our self, or this actor. Now, out of the new rotation for our set actor rotation, we're going to drag out of this and find look at rotation. And we're going to connect the return value for our actor to the start location, and the target actor that we want to look at is our interactor for our target location. Now, when we interact with our actor, it's going to rotate this character, which is going to look at the player, but it's going to rotate all axes, which is going to be the X, Y, and Z axis, which we only want the Z axis to really rotate. So we can actually break the return value for either one by holding the Alt key and clicking, or right click and there should be an option to break the link. Now for the return value of our lookout rotation, we're going to right click and select split struct pin, because rotators are structs, and for our set actor rotation, we're going to also split this struct. And we're only going to connect in the Z or yaw value, because we only want it to just turn to our player, not to look down, which will cause it to clip to the ground, which is not what we want. And if you want a blur effect to occur, you can leave this unchecked. If you don't want a blur effect to occur when he rotates, you can just check the teleport physics. And then we're going to draw a debug string as our hello message. And we're going to use our actor's location again for the text location. And the message is, I don't know, why hello there. And let's use the color purple as well for this one. And our duration we will set to 2.5. The reason why we don't have to put in a test base actor is because it really isn't important, and it won't really affect it in any way. Let's compile and save. And now what we have in this actor is when we interact, we're going to get the look at rotation, and we're going to rotate our actor to look at the player, and then we're going to print a little message saying hello, or something representing that we identified that the player interacted with us, other than just the rotation. In the next video, we will be allowing the player to use our interaction system.